All right, so welcome back to another video. Um, I'm going to continue where I left off and just talk about um, how to calculate compensations. And you calculate appropriate compensations um, by applying specific formulas, and you apply the specific formula based off of what the primary problem is. So it's pretty straightforward, okay? So let's just go left to right here, okay? First, we're starting with a respiratory acidosis. What is a respiratory acidosis? It's an increase in CO2. Okay, so what's the appropriate response in an increase in CO2? Well, you're going to increase your bicarb concentration. So the question is, how much should your bicarb go up? Well, if this is an acute problem, the body does not have enough time to change the bicarb. So the bicarb change is going to be less for an acute problem per change in CO2 versus a chronic problem. That should make sense. So again, acutely we have an increase in CO2. And the formula we need to apply, we're predicting the change in bicarb, right? So our formula is going to be, and we're predicting the increase, right? CO2 goes up, bicarb should go up. So for every 10 changes of CO2, acutely, bicarb should only go up by 1. So this will be acute 10 to 1. What does that mean? That means if a patient has a CO2 of 60, then what should the increase in bicarb be? Well, it's changed 20 from baseline, so therefore bicarb should go up 2. Okay. Now, chronically, again, respiratory acidosis, you're going to have an increase in CO2, but your body has more time to correct the bicarb concentration, right? So we'd expect a greater increase of bicarb if this has occurred over a chronic period of time. So the change here is actually going to be, let's see, so for every 10, we're going to get 3.5. So example, again, CO2 is 60, then we should get an increase in bicarb of 7, because again, that's a 20-point change from baseline. And that's what we're predicting, okay? Winter's formula, the old famous Winter's formula. I'm going to talk about acidosis in a completely separate video, but it's regardless of what acidosis you have, whether it be a non-anion gap or an anion gap acidosis, you can always apply the Winter's formula to check to see if the patient's compensating well. Okay, so what is a metabolic acidosis? By definition, metabolic acidosis is a decrease in bicarb. What are we going to expect change to be by the body? Well, always in the same direction, so the change should be a decrease in CO2. The question is by how much? How much should the CO2 decrease? Our formula is CO2 is equal to 1.5 times the bicarb plus 8 plus or minus 2. Easy. And I'll go through many examples of that in a later video. Again, we're coming down to our alkalosis here. And again, because it's a respiratory problem, and the way to correct a respiratory problem is through changes of bicarb, you have chronic and acute ways to change your bicarb. So let's first start with our acute state here. And let's take an example. So acutely, we've identified a respiratory alkalosis by definition. That's a decrease in CO2. What do we expect the bicarb to do? Same direction. So we're calculating the decrease in bicarb. Okay, so acutely, for every, let's see here, for every drop in CO2 by 10, we should expect a decrease in bicarb of 2. Okay, so example, let's say CO2 is 20. It's a change of 20 from baseline. So we'd expect 2 for every 10, so that'd be 4. So the drop in bicarb should be 4. Now chronically, again, because we have more time to correct, we're going to expect a greater drop in the bicarb, right? So let's calculate how much, using the same example, how much decrease in bicarb. Chronically, for every 10, the drop in bicarb can be 4. And the way that I like to compare or to remember this is that the body is better at getting rid of things rather than creating or reabsorbing. And so that's the way I remember that the drop in bicarb acutely can be greater and chronically, so 2 and 4 versus 1 and 3.5 of the reabsorption or generating bicarb. Anyways, sticking with our same example here. CO2 is 20. Then we'd expect the change of bicarb to be how many? 8. Okay, and last but not least, we've identified a metabolic alkalosis. What's a metabolic alkalosis? By definition, metabolic alkalosis is going to be an increase in bicarb. How do we compensate for that? Same direction. Increase our CO2. By how much? Let's apply a formula. So the formula for this says that with the amount of change in carbon dioxide, okay, so first of all, we know the bicarb, and so we're calculating the change for CO2. That needs to be first identified and stated. So what is the CO2? Well, for every change of 10 in bicarb, you're going to have a change in CO2 of 7. This is kind of the exception to the rule that we saw elsewhere. So, example, let's say that we have a change of bicarb of 34, so there'd be a change of 10, and our CO2 be expected to increase by 7. Okay? So this should equal 47. All right. In summary, when you have an acid-base problem at hand, number 1, look at the pH. Number 2, look at the bicarb. Identify what problem that you have, and then ask yourself, if I have a decrease or an increase of this, how is the body going to compensate? And then apply the compensatory formulas appropriately to identify if you have a mixed disorder at play.